Aloha, Rich Halverson here. This is ITS128. And today I'm going to cover Chapter 9, the chapter on classes. So let me share my screen. All right. We are down here. We're a little behind Chapter 9 classes. But it's probably the most important chapter in the book. So let's get started. Classes. A class, a class is a definition of a particular type of object where there can be many instances of it. Okay, so the physical world, for example, is made up of various materials, but we don't think of things as we look around as these various materials. We think of them as higher level objects like chairs, tables, TVs, and so on. The lower level items can be things like what they're made of or what they do. And so to keep programmers understandable, we bring the same concept into our programming. In programming, an object is a grouping of data, or in other words, variables, values, and operations. And when we create or define or declare an instance of an object, then we're able to do things like set certain variables or set certain values, properties, and then there's also methods which may come along with it that can do operations. Well, printing information about the object is one thing. It's a common method that's added to most classes. You're able to easily see the characteristics or the attributes of the particular instance of the class. Now all these words will come to make more sense, hopefully by the end of the chapter. And so here's a participation activity just to see if you sort of understand the concepts here. So let's just go through this and try to explain it. A program consists of variables and functions and methods, but programmers may prefer to think of higher level objects like restaurants and hotels. And so we have a bunch of things variables here, which we might keep as which would be attributes to something. But for programmers to keep all of this organized, we might think of a class or a class type or a type of object called a restaurant. And then that restaurant does have these variables that are associated with them. And in fact, they're associated with all restaurants. And then a different kind of class would be a hotel. And some of the attributes are similar, have a name, phone, and reviews. But a restaurant, of course, would have cuisines, and a hotel would have, not have cuisines. They would have, in this example, amenities. And so here this concept of objects, and so some of the variables and functions for a used car inventory program would be grouped into an object type called car, or car on a lot, car. And what we're supposed to do is see if the item would become part of car on a lot, object type or not. Car sticker price, I think that's true. If you have an object named car on a lot, there would be a sticker price associated with it. Yes, that's true. Why would today's temperature be associated with a car on a lot? It would not. Days on a lot, that might be one. Let's see if it's true or not. Yes, it is. Original purchase price, yes. Number of salespeople, no. This number of salespeople doesn't have to do with a particular car on a lot. It has to do with the car dealer. The car dealer may have many instances of cars on a lot. So I'm going to say this is false. And so anyway, you can go through this to make sure you understand that. The second concept is we have this thing called concept of information hiding, or there's certain information that goes along with the object that doesn't really ever need to be visible to the programmer or to the user of the object, but it's going to be some data item that some value that is used to keep track of something internal that the methods of the object would use. And so objects, make sure you understand this concept. Name phone. Okay, so let's just start this up and see what it looks like. Abstraction, an oven is viewed as having a compartment for food and a knob that can be turned on for heat. That's how we view an oven. But people do not need to be concerned with the inner workings. People don't reach inside to adjust the flame. You don't have to do that. You don't do that. That's the oven controls the temperature. And similar to the object, an object has operations that a user can apply, like, you know, turning it on, turning it off, setting the temperature, but there's internal data, you know, that it uses to provide these methods for the user that the user specifically doesn't need to have access to. And so that's this idea of abstraction and information hiding. And we're going to see this a lot more in this chapter. A car presents an abstraction to a user, including a steering wheel, a gas pedal, and a brake. Yeah, that's true. That's how we think of a car. A refrigerator consists of an abstraction to a user, including freon gas, a compressor, and a fan. Well, the user doesn't really think of a refrigerator as something that's got freon gas in it. You know, how much freon gas does it have in it? Left. A compressor, it's really more about it's got a door. It's got a compartment to put stuff in that can close the door, the temperature setting, so on. So I'm going to say false. Okay. Yeah, these are inner workings. They're not things that we think about when we think of a refrigerator. So a software object is created for a soccer team, and a reasonable abstraction would allow setting the team's name, adding or deleting players, and printing a roster. Yes, that's what we would think of. We're going to create a class of objects that are with teams or whatever. This is very reasonable. This is a way to think of it, and so I would say true. Okay, so you can go through this and make sure you understand that. So Python automatically creates built-in objects that are provided by the language program for the programmer use. Like, for example, if you have a string, if like you have any kind of string like this, you have a string object. This is like really in Python, you don't think of this as a variable. You think of it as an object because you set it. Once you set it equal to the string, then a bunch of methods come along with it because it's a string. You can see if it is a digit, if it's all digits. You can see if it's, or you can set it to being all lowercase. You can modify it this way and so on. So, and a string type that comes along with all these objects, that's built in. In this chapter, we're going to learn how to create our own objects and then our own methods that go along with it. We're also going to learn, we're also going to learn a concept called overloading, where we can take the Python definition of a method and overload it and change it or add to it. So that's pretty cool. All right, so the Python programming language provides a built-in object for strings. Yes, it does. Built-in objects include useful functions. Yes, built-in object includes every function a programmer could ever find useful for dealing with strings. No, that's not true. All right, you can take that survey. Okay, so classes, that's when we define our own objects, we start by defining a class, or that's a template for the object. And then after we've defined this class, we can create instances of the class, which are called objects. There are built-in classes like string, and and dictionary and list, those are built-in classes to Python. Those come with Python. And along with those comes values like a list is going to contain probably a hidden variable in there, which contains a number of elements in the list, because you might want to a common method is the length of the list. What's the length of the list? Well, the Python runtime machine underneath is not going to have a method which every time the user asks for the length of the list, it counts up all the elements in the list. I mean, there could be a million elements in the list, and so that would take a while. Instead, undoubtedly, there's a variable in there that we don't see, but the Python runtime machine keeps track of it. Whenever an element is added to the list, that variable is incremented, that hidden variable is incremented. Whenever an element is removed, that hidden variable is decremented, and so on. So that's the idea here. So we're grouping data. So let's say we define a new class called time. So and it's a time object, and so basically it's used to represent a particular time of the day. Let's say it doesn't keep track of the date, but it just keeps track of the time of the day. Well, if we were just to have a simple, there's, in this particular class, that definition, we're going to keep track of the hours, 0 through 23. And then we're going to keep track of the minutes, 0 through 59. But we're not going to keep track of seconds. It doesn't look like we're going to keep track of seconds. But anyway, so, we have to create a new type of object for this, because it's not an integer. There's like two components to it. It's not a string. It could be like a tuple, I guess. But here we've defined this class called time, and then we can use that time class to create instances of a time object. This object that's keeping track of a certain time, a particular time. Let's say you have a calendar thing, and you have certain times that are in your calendar. Perhaps you would use this approach, and you would create time objects. Well, here we have this class called time, and this is what's called the initializer, or the constructor. We actually call it the constructor. And basically what it is whenever anybody creates an instance of this class, there is going to be, coming along with it, there is going to be an hours attribute, and there's going to be a minutes attribute. See, that's what this says. And this is how we define, this is how we use the time class, and we create an instance. So we're going to create an instance of the time class. So it's this object, and along with that object comes this hours attribute and this minutes attribute. And so we're able to set the hours, we're able to set the minutes, okay, just like this. And then down here we can print them out. Say we got this, it prints out whatever we had set the hours to, prints out whatever we set the minutes to, and we see that prints like that. Okay, it's very simple, very straightforward. It's all obvious. It's all obvious. There's nothing really new. Really what we're doing here is we're learning the terms for these things. And the reason we're learning the terms now is because we're going to learn how to make our own classes. All along up to now, we've been using built-in classes, but we've been certainly using classes. We've been creating instances of classes and so on. This reference operator is important. It's the member operator. This is the name of the object which you have created, which is of a type class, and then there's this dot reference operator, and this is an attribute of this object, and so on. Here's an example of using this class object more than once. We're going to create one over here. It's got these attributes. We're going to create another one called time2. It's got these attributes, and so we're able to print time1 and time2. And look, it's different because they were set differently. Very simple. This make sure you understand the terms. This is name following a thing symbol would be the name following would be like attribute, and a method parameter that refers to the class instance itself. It doesn't, here we always see this self. All throughout the whole book, you see self. You don't need to use self. You can use anything, but whatever you put there has got to be whatever that is. And self, it makes sense to use self because. So anyway, make sure you fill out all these. A class can be used to group related variables together. Yes, I think it is called automatically. Following the statement, T references an instance of the time class. Yes. Is that true? Yes. Okay. All right. So what is the value of T time hours? Okay, given the above definition of the time class. Okay, all that, okay. What is the value of time 1 dot hours after the following code is executes? Well, I don't think it has any value. So is it like none? I don't know. Is it none? I'm not sure what they're after here. What is the value of this after this executes? Let's see what the answer is. Oh, it did do that. Let's see. Yes, it did. It initialized it to 0. So that's what the answer is. All right, so the answer is 0. Given the above definition of the time class, what is the value of this after the following code executes? Well, now it's 7. There's various ways that this can be initialized. These can be initialized, as we'll see. All right. So make sure you understand that. Okay, so here's a challenge activity. We're defining a class called person, and we're initializing the name as nothing, and then we're creating an instance of it, and then this setting username equal to that is a variable. This is a variable which is, this is a string object, and then so here we're setting whatever this value was to that, and here's person. So here we're printing it out. So that's why this prints. So we can. I am Noah. So you can make sure you understand that one. This one, declaring a class. Declare a class named patient data that contains 2 attributes. Okay, so so in this code, we're going to create a class called this that contains 2 attributes. I guess it would be something like a class patient data, and then I always got to make sure I get the syntax right on this. Where are we defining a class? Okay, we put a colon there. I'm going to copy this here. Put a colon there. This. Colon, and then yes. Okay, but here we're going to have, it's going to be called height underscore inches. And this is going to be height underscore, weight underscore pounds. Okay. And we will initialize them at 0. Yes, okay, so, this is before, okay, so here. And so this is telling you that before the patient data, before you set it. All right, so in this code here, we've we've defined the class called patient data. This creates an instance of that class. This prints out, this is going to print out the height in inches and the weight in pounds. And because we haven't set them to anything, it should print this out. And then after that, we're going to ask the user a value, and it's 63. Excuse me. And then we're going to ask the user a value, and that value is going to be 115. And then afterwards, it should say what the it sets those values, those attributes in this patient object, and then we're able to print out the afterwards. Okay, so you should be able to figure this one out. What's this one? Print the attributes of the inventory tag. Okay, so here we created a class. Let's see, this is probably right. So we've created a class called this. Oh, shoots. Yeah, that's right. And so now we create an instance of it, and we're going to set the item ID equals something read in, and we're going to set the quantity remaining into something that was read in. And then what are we supposed to do? We're supposed to print this out. It's going to be something like print ID colon comma red sweater item ID, something like that. And then you got to do it for quantity. I think you can do that one. All right, what's next? Instance methods. Okay, so far we've talked about how to define a class and how to create an object based on that class. But our classes have only had attributes. They've only had variables. Well, so they can also have methods. They actually have had methods because we needed to have a method to initialize it. The constructor is a method, but we can have other methods also. And a common one to have is some sort of print method that prints out, where you just call it and it prints out the information about the class that that is pertinent or is relevant to, what the object is. The particular attributes, you print out the particular attributes, attribute values of the instance of that class instance. This is all about learning terminology. I remember back in the old days when in the early 1990s when I was teaching ITS128 at Manoa, and we didn't have classes. We had structures. We taught using a language called Pascal, and we had structures. And we started, some of this terminology started seeping in. And then when it came to classes, one thing about you as a programmer is if there is a huge paradigm shift, let's say you're out there and you're a programmer for 10 years, and there's a paradigm shift like there was when classes came along. You may not need to adopt that new method of coding because you're busy working on a project, or you're working on maybe a legacy project, and it's still written in old code that didn't use the new paradigm, and so it's 5 or 10 years later before you actually have to use it because start to work on a new project, and you got to learn this new language, and there's going to be features in the language that force you to do stuff, that force you to do the best practices. And it's all learning the terminology because it's all stuff you've probably done already. It's probably sort of routine best practices that you've been doing already manually. So you shouldn't be afraid about any of this stuff. When we're throwing all these terms out here, you just shouldn't be afraid of them, and it all just kind of makes sense when you think about it for a little while. All right, so here we define this method called print time, and so we can call it just like we when we refer to an attribute. Here we are calling the print method, and methods are always called with left paren, right paren after it, so that's how you can tell. Plus, this is sitting out here all by itself. It's just means execute me, whereas this is actually assign this, the value of this, and this here is just execute me. All right, prints that out. All right, so this makes sure you understand what's write a statement that creates an instance of an animal called cat. Well, I guess you just do cat equals animal. I think it's something like that. Write a statement that calls the noise method of the cat instance with the argument meow. Okay, so there's an argument there. So I guess we would do cat dot noise left parentheses, and self is you don't think about that when you're calling it. You just say meow. I guess we're gonna have to say MEOW. I think we have to put that in quotes because this is in quotes. So let's see if this is correct. Yes. All right. Let's see, adding methods to a class. So here we're adding a method called calculate pay to the employee class. All right, well, I don't need to, I was going to go to do a REPL, but I think I'll just talk through this. So the method should return the amount to pay the employee by multiplying the wage by the hours. Okay, so we're going to put the method right inside here. I'm going to take this comment out. Oops. And I'll take this line out. And what do we want to name it? We want to name it calculate pay. We want to name it calculate pay, def calculate pay. And I think we just do this and put a colon there. And again, this is a syntax. No, we got to put self there. We got to put self, don't we? Yeah, put self there. We don't have to put anything else because we have, let's see if this works. I'm going to spell it wrong, LEF. And then we say return self.wage times self hours worked. Oh, but I call it SLEF by mistake. So I'm going to see if that works. It should work. I bet it's not going to work. I'm not going to do that. I'll make that point some other day. I'm worried because that's the name there. All right, so let's see if this works. Employee has no attribute called hour worked. Hour worked. Hours worked. That's nice. Okay, Alice is making 323. Okay, so now I'm going to try to see if this works. I could be wrong here. LE. LE. I'm going to make this LE also. LE. LE. And LE. Just to prove my point. Oh, see, it works. Now, what happens if I make this self, and this self, and this self? Does this still work? Yeah, it does. Okay. Well, anyway, but don't do that. It'll confuse people. Or if you miss, if you misspell self, make sure you do it consistently all the way through. All right, so notice that init is also a method, so you actually can call init indicating method implementing special behavior. Is a special method name. Good practices to avoid using double underscores in identifiers to prevent collisions with special method names. Okay, so all they're saying here is that, this is convention, Python convention. But if there are going to be any special methods, they're going to be named with 2 underscores in the beginning and 2 underscores in the end. And we're actually going to talk more about that farther down. But so now there's no reason. So they're saying when you name your own variables, don't name them using this convention, or don't name them with like 2 underscores in the beginning and 2 underscores in the end, because you might be conflicting with some actual special method that you don't know about, or some new one. And your code might work for a while, and then 10 years later, 2 years later, it doesn't work anymore. Why? Because Python came out with a revision and they added a new special method in there, and they named it the same as yours or something like that. So anyway, that's all they're saying. And there's other cases where they tell you a certain convention, and because there's certain things that are enforced in other languages that are not enforced in Python. Like for example, being able to actually hide variables in a class. In other languages, you just say this attribute is public and this other attribute is private, so people outside cannot get at that private attribute. But there's no such thing as a private attribute in Python, so it's more trusting language, I guess. All right, so here we're saying if you forget to put the self in there, it's going to cause an error. Yeah, of course. So you got to write a definition of a method that has no parameters. Add point. Oh, I don't put a colon after that. I guess not. I do. What am I doing? Oh, there's a colon right there. Oh boy. Sorry. All right. Okay. Challenge activity here. Here we're defining a name and we're printing it out. And so what's the big deal here? Here we're just defining an instance of person. When we do that, first name is initialized as blank. And then we set the first name equal to Joe, and then we print it out using this method here. Okay. Anyway, you can make sure you understand that one. Defining an instance method. So define an instance method. It's a method called where it increments the number of kids for this one. So kids is 0, new baby. Okay, so we're supposed to write a method here, like def inc num kids. Gotta put the self thing. And when you call it, you're just doing this. So it doesn't have any more parameters other than that. And I guess all we're doing is we're incrementing num kids. We're incrementing this. So to increment that, it's self num kids. You can increment by just doing that. I don't know. That's probably what the answer is. All right, what's next? Class and instance object types. So sometime around here, I'm going to skip over. Okay, all right, I'm going to do this class example. I'm going to do this one, and then I'm going to skip down. I'm going to do this 911, and then I'm going to go to, I'm going to cover class constructors and maybe a little bit of interfaces. The rest of this here is we can get to later. Do we do any overloading? Okay, anyway, we'll see that. Okay, class and instance object types. So a program with user-defined classes contains 2 additional types of objects. Yes, okay, there's class objects and instance objects. That's all we're talking about here. And this is a class object, and this is an instance object, and this is an instance object because it's an instance of the class. Now we can get at the attributes of the class definition, and we can get at attributes of the instance of the class, the object of that class attributes. So this here, this is the name of the class, you see. And so when we print out, this is the class name followed by this, we're printing out this, whatever this is here. And then now when we define new instances of this class object, this is like it's like a constant. It comes along with it, and it's not anything that I guess you can change it. Anyway, so when this is created, this is executed, so it's part of the class definition. So these 2 things, these are gonna have that value. And that's the point here. See, these are 3 of the same. But an instance attribute can be unique to each instance. Here we have up here we have marathon runner. Oh, we didn't really say anything here. Race is okay. Here we're referring to that. Okay, but here we have we have this marathon runner. We have this race distance, and then when we're creating a new instance of marathon runner, you know, like this or like this, then we're also going to add this this instance variable called speed. So this is going to be an attribute of the instance, not an attribute of the class. So, you know, here we can set, first we create the runner that's got this race distance here, but then we can set a speed value for each different instance of marathon runner. Here, this runner number 1 runs at this speed, and runner number 2 runs at this speed. They both have the same race distance attribute, but they have different speeds. So that's the only point here. There can be class attributes and instance attributes, and you can get at both of them. See here, we're in this example, we're just showing that even though these are different objects, we print that, and this kind of shows how it looks inside the Python runtime machine. Okay, and let's see. Now this is going to tell us whether or not we can mess with this. I think we can mess with this. And so here, so changing the GMT, changing this value in this class affects the behavior in all instances of the class. So here we're creating a time, and we're setting hours, we're setting in minutes. I'm creating another one, setting another hours and setting another minutes. And we are printing out what the time is. And it's got this GMC offset. You add this GMC offset. In Hawaii, our GMT offset is -10. But this would be like Greenwich Mean Time over there in London or someplace over there. And so this prints that out. Now we're gonna change this value. And so to do that, we referencing the time class, and we're going to set it equal to that, which is Pacific Standard Time. Okay, I already told you Hawaii time is -10. Pacific Standard Time would be in the winter time. Are we in the winter? No? Yeah, we are in the winter, so that's accurate for what it is right now. Once we change this offset, then that means that this changes, and that means that this changes, because this is the same as this. No matter what the object is, no matter what hours and minutes are, the GMT offset is going to be this, and this is the same as this is the same object in all of the instances of the class. So anyway, you see what's going on here. You change this, and then when you print the new time, it's going to change. It's going to change there too. So so anyway, all right. So what type of attribute is number? It is a instance attribute, because it comes underneath the init is the constructor to create an instance of this class, and in the creation of an instance of this class, it's going to throw in a attribute there. It's going to throw in a place for the string here, and so this is an instance. Is this right? Am I right? Yes. What type of attribute is number? Again, it's the instance type of. What's the difference between? I think it's still an instance attribute. Okay, what type of attribute is area code? This would be a class attribute. All right, classes and instances. Okay, so just go through this, make sure you understand the difference between class attribute and instance attributes. Okay, here's a nice program here. This is a seat reservation program, and here we're creating a class called an instance, and it's basically holding a seat on an airplane for a person, and these are the three attributes. And there are methods that go along with creating an instance of the seat, and so it is. There's a reserve method, and there you assign a first name and a last name and the amount paid. There is a make empty method, which clears out those attributes, sets them to nothing or zero. There's a method which tests to see if it's empty or not, and this is gonna be true or false. That the first name is equal to blank. It's either going to be true that the first name is equal to blank, or false that the first name is equal to blank. If the first name is equal to blank, then you know the seat's empty, so it's going to be true. So this is going to return a true, and the seat's empty. And this just prints out the seat, and it's going to print out all three attributes, so we know it's going to print out the first name, and then the last name, and then the amount paid. And it's going to print out the first name and the last name, comma, and then the amount paid as a floating point number with 2 digits to the right of the decimal point. This is okay, so so we're done with the definition of a class. So when you create an instance of a seat, we're done with the definition of the class definition of seat. So when we create a new instance, we get these 3 attributes plus these 4 methods along with it. Okay, so now we're starting into the main program. And this method here empties out all the seats. How many seats are there? Excuse me. This is a variable which gives us a maximum number of seats on the airplane, I guess. This is going to print up, so this ranges through all the seats. No, this is a list. This is going to be a list. And it's going to be a list of objects. Where do we see that? Okay, this is going to be a list, and we're going to be appending objects. Okay, so this is kind of an interesting 3 lines of code right here. So we declare an empty list, and then we're going to loop I going from 0, num seats is 5. So I is going to go 0, 1, 2, 3, 4, 5 of them. 0, 1, 2, 3, 4. And each time it's gonna append an empty seat object. So when you see this, you are seeing this sitting there all by itself is going to be replaced by the Python runtime machine with an actual instance of the object or a pointer to a new area in memory that's set aside for this object. A better way to put this would be new seat, just keep it more clear. So I got a new seat, which is this seat object, and then append new seat onto here. That might be more understandable to you. So this creates a new object called new seat, and then we're going to append that new object onto here. This should work. Excuse me. And then when this is all done, we've created a list of seats, of empty seats, of 5 empty seats. And each of those seats has these attributes. And also each of those seats comes along with these 4 methods here, which can be used to operate on that object. And here we ask the user to enter a command, and the user is going to enter in a P or an R or a Q or nothing, or an invalid command. So while the user does not enter in a Q, in other words, while the user does not want to quit, we first check to see if the command is a P. And if it's a P, then we're going to print all the seats. Available seats, prints all the seats, prints this list using this method that is given to us. And or the command is an R, which means you're going to add somebody in there. And so it asks what the seat number is, and that's going to be 0, 1, 2, 3, or 4, because that's the only valid elements in the list of available seats. Those are the only valid indexes. This is an index. It's a list. This is an index. If it were a dictionary, that'd be a key, but it's not. It's a list. And so this just tests to see if that particular object is empty by executing this method here. And if it is empty, then it goes ahead and asks the first name and the last name and the amount paid. And once those values are read into these variables, we call this reserve method for the particular seat number, the valid seat number that the user entered in. And these are the arguments to this method. That would be this method here. These are the incoming parameters for the execution of the method, and it sets the first name, last name, and paid. So here we we see that we've set it up so the first command is going to be an R, which is reserve, and the next command is going to be seat number 1. The guy's name is Hank, and his last name is Hill. And then we're going to, this is how much he paid. And then we're going to reserve another one in seat number 2, guy named Bobby Hill. That's how much she paid. And then we're going to print, and then we're going to quit. Okay. So anyway, this is what it looks like when we run. And so enter a command, that'd be this. Anyway, this works a lot better if we run it someplace else, like in a REPL. I can quickly do that. Let me make Teams 128, create a REPL, and I'm going to call it Python REPL, and I'm going to call it this. And I'm just going to quickly copy this code over here. And I guess I can, and let's copy this. This is what they want us to run. So I'm going to copy this, copy, and I'm going to say run this. Oops. So this is the code. This is the first. All right, so let's just run this. See what it does. Enter command. I'm just gonna enter right down the line here. So the first thing I'm gonna enter is R, and then I'm gonna enter seat number 1, and then I'm gonna enter Hank, enter Hill, and I'm gonna enter amount paid is $275.63. And then I'm going to enter 2, seat number 2. So command R for reserve, seat number 2. And this guy's name is Bobby, or this person's name is Bobby Hill. And this person paid only $245.22. Tell you what, I'm going to print. I want to see what the print looks like. Look at that. I'm 0. What does this do now? Okay, yeah, see, so the problem is nobody asked to be put in seat number 0 because it starts with 0, see? So there's nobody in 0. There's Hank is in 1, Bobby is in Hill, Bobby's in 2, and then nobody's in 3 and 4. Anyway, let's see if quit works. Should work. Oh, let's see if some, we already know that a invalid command works. I put in 2 for an invalid command. Quit should work. Q. All right. So, all right. Let's do. Let's just do 9/11 here. All right. So let's create a REPL to do this. And I'm going to do this one. And I will copy this. Copy. And done. Okay. And then I'm going to copy the starting code. Okay. And is there anything others? Any other special thing I need to know? No, it's all over here. All right, so we're going to complete the car class by creating an attribute called that. It's an integer, and then we're going to create a method called that prints the car's information. And so if the input is first going to ask the year of the car, then I'm going to ask what the something is, purchase price, and then we're going to or 2 is a model's year, 18 is a purchase price, and 2018 is the current year. And so then it's going to output this. Apparently there must be some sort of depreciation thrown in there. Yeah, depreciation rate of this. All right, so let's get out here and see what they give us. The first thing we're doing, and by the way, just so you know, sometimes we see code that has this in here, and sometimes we see code that does not have this in there. All that is when we put this in there, then the auto grader can actually take your submission and call that a module, and it can be a separate module, and then it can do unit tests. Then it can actually test the class without executing this code. So that's what this is there for. Most of the time you don't need to put that there if you're just going to write some code and you're going to execute it, and you're not ever planning on using your code as a module for some other code that you're going to write in the future. Anyway, so I'm going to put some notes in here. Enter year, enter model year. And this one I want to say enter original price, spelled incorrectly. And then I'm going to put original. Then I'm going to put current year. Okay, so this creates an instance of my car. This is going to set this attribute of your car of my car equal to whatever you entered in as a year. It's going to set up to purchase price. This is going to calculate what the current value is by doing that depreciation thing. And then this is going to print it out. So we're supposed to create this. Okay, self model year is going to be equal 0. I need to put a purchase price in there. So I'm going to say self purchase price equals 0, I guess. And current value is equal to 0. Okay, that's all three, but model year, purchase price, current value. Calculate current value takes calculate car depreciation. The age, this is the number of years. Oh, I don't need to add anything in here. Okay, this is a comment. This is a comment for what this is. And what it is it's it figures out how many years old the car is. And then it takes the car's age and it takes, this is the formula for the current value. It takes the current purchase price, multiplies it by 1 minus the depreciation rate, which would be, so 1 minus the depreciation rate would be 0.85, because 1 minus 0.15 is 0.85. So it's 0.85 to the car age power. So if the car is 4 years old, it's 0.85 to the 4th power. And then that value is going to be multiplied by the original purchase price, rounded, and that's what the current value is. Now, somebody else is going to give you this formula. Why? because somebody else probably wants to make sure that it's correct. And you're the programmer, you're going to make it all work. But there's various methods of depreciation. I mean, you know, this is just one. This value here in particular is you know, debatable. So, but the point is this formula here, you might be given that formula as, let me clear this out. This is from a long time ago. I'm gonna so you might be given this formula. Let me figure out a way to show this one as purchase price times you know, 0.85 to the age power, age in years power. This is times that. So if this is like $10,000 times 0.88, sorry, 0.85 to the fourth power. Okay, so you might be given something like this, where this is the age, which is the current year minus the year it was made, and this is the depreciation rate, 1 minus the depreciation rate, and this is the original value. And you have to take a formula that looks like this and convert it into something that looks like this. Purchase price times 1 minus depreciation rate to this car age power. So you got to be smart enough to know that. So that's how you do power, and this is multiplication, and this is rounding out, because otherwise it's going to be a whole bunch of decimal point digits to the right of decimal point and so on. So the programmer, that's what you're going to do. So anyway, and then we're going to have to do a print info. Yeah. Print info. And I'm going to just do a colon here, and I'm going to make this a comma. So I'm supposed to print out the model year purchase price and current value like this. Okay. All right, so I'm going to say print cars information. And then I'm going to say print space model year is self model year. And then I got to do the same for purchase price, print purchase price is self dot purchase price. Now, why am I getting squigglies? Why am I getting squigglies? Because I forgot to put self here. What's this? Purchase. Oh, it should be a period purchase price. There we go. No more squigglies. And then you gotta make sure you do the last. There's another one here, and that's going to be this. So you can figure out that part. You're going to call this method, and Oh no, I guess this does that. So anyway, I'm gonna see what this does. Wish I knew how this thing. Wish I knew how to start this. There must be an easy way to start this thing up again. Okay, now it says connected. Okay, run. All right, enter model year 2011. Purchase price 18,000. Current year is, I don't know what the current year is. 20. What's supposed to be 2018, I guess. 2021. And it says, gives me the model year, gives me the purchase price, but it doesn't give me the depreciate the current value, because you have to do that. All right. So that's 9/11. All right. So I'm going to, the next question is where we are actually creating constructors, aren't we? Create a constructor with parameters to initialize instance attributes, and so that's 9/12, and that is we've gone up to 9.5, and we haven't covered 9.6 yet, which talks about class constructors. And so I'm going to end this video now and start up a new one, starting with 9.6. Okay. So I've covered 9.1 to 9.5 and lab 9/11. Hope that helps. Thanks for watching.